All right, this is our 3 notes, justifications, and intro to proof. Now, guys, this is can be kind of challenging, but if you pay attention and just remember, we really already know how to do this stuff. It's just now we're writing down our steps. That's all we're doing. We're writing down our steps. So, the goal today is we are going to justify mathematical statements with properties and definitions. Now, this word justify should seem familiar. We talked about it in Unit 2, and that's really just explaining why we did what we did. Okay, and we're going to learn some properties and some definitions today that'll help us do that. But first, let's go over stuff we learned last Thursday and practiced last Friday. So, writing conditional statements along with their other conditional statements. So if you remember, our if-then statements are always given in if P, then Q. P is our hypothesis, Q is our conclusion. The converse of that is just flipped around. Remember, we flip our converses. And then the inverse is the opposite. To do the inverse of something is to do the opposite. So we negate it. We say, if not P, then not Q. And then the contrapositive does both. It flips and negates. So we say, not Q, then not P. Okay, so I always think that through before I jump in. It helps me keep it straight in my head. Okay, so first statement, it says all rock stars are bad actors. Well, we've got to turn that into an if-then statement. Now, there's a couple ways you could say this, but the way I'm going to say it is if the rock star is a bad actor. No, let me back up. Sorry, I added too much. See, even I myself, I'm just trying to rewrite the statement. Okay. So if the star, there we go, is a rock star, then they are a bad actor. Sometimes coming up with that if-then statement can really throw you for a loop, okay? So if the star is a rock star, then they are a bad actor. That's how we could change this statement to an if-then. Now, remember the P, the hypothesis is what comes after the if, and the conclusion is what comes after the then. Okay, so I still go in and kind of underline and label my P's and Q's because again, that's going to help me. So remember the converse is we flip it. We say if Q, then P. Well, let's say that. If they are a bad actor, then the star is a rock star. Okay. All right. To write the inverse of that statement, remember we negate it. So we say if not P, then not Q. So we still follow this form, but we negate both of those statements. So if the star is not a rock star, then they are not a bad actor. Okay. Last one, the contrapositive. Now remember, contrapositive, we just talked about, it's negating it and flipping it. So it's if not Q, then not P. And remember, those are little squiggles. They are not ends, but they kind of look that way. So contrapositive. So we would say if they are not a bad actor, not a bad actor, then they are not a rock star. All right. That's what we had been working on. Okay. Don't forget it. It's really important. Keep studying your vocab and all that good stuff. Okay. All right. Now, guys, this is all of our and probably not all of them, but for right now in our lesson, this is our properties of congruence and equality, okay? So some of these, the good news is a lot of these are going to sound very intuitive, like you're going to be like, well, duh, of course. And then some of them you'll remember from Algebra 1. So that's, kind of nice because if you look at this, like the addition property, subtraction property, multiplication, division, distributive, like you know those from algebra. So that's good. Now, the reflexive property is very simple. It is something like A equals A. 5 equals 5, 100 equals 100, 3x equals 3x. It's reflexive. It's like a mirror. I know it says reflex, but I also think of it as like reflect, right? It's the reflective property, but we say reflexive, okay? So you will need to remember the reflexive part, but it is what it is, right? Like A equals A. So now the symmetric property says that if A equals B, then B equals A. Okay, so that one's kind of nice, right? If 3 equals 5, well, that's not really true, is it? If X equals 5, then 5 equals X, right? Like you can flip them around and you still get the same thing. That is what we call the symmetric property. Now, the transitive means that if A equals B, and B equals C, then A equals C. Okay, so transitive, like I think of transit when I hear transitive, and transit means like it moves. And so I think about, we have these two statements and we're moving it to say that, the other two equal the same, right? So if we know that they're both equal to B, then we know that A and C are also equal to each other. Now, I know right now this seems a little abstract and it's a little weird. Once we start doing some examples, you'll see what we're doing, okay? Now, the addition property of equality should be something that you have seen before. It says if A equals B, then A plus C equals B plus C. Okay, so basically you can add C to both sides and you're still going to get the same thing because we've still got A equals B. Okay. The subtraction property is just like the addition, only we subtract. So we say if A equals B, then A minus C equals B minus C. Okay, now again, right now this seems really abstract and kind of hard to wrap your brains around. Once we see some examples, it'll make more sense. Okay, all right, multiplication property. If A equals B, then AC equals BC, meaning we can multiply both sides by C and it will still give us the same thing. All right, division property. If A equals B, and really important, C does not equal 0 because we can't divide by 0, then we know that A divided by C is the same thing as B divided by C, meaning you can divide by C on both sides and still get the same thing. But again, C cannot equal 0 because you can't divide by 0. All right, distributive property. That should seem very familiar. So A times B plus C in parentheses is the same thing as A times B plus A times C. Okay, and then last, substitution. If A equals B, then A may be replaced by B. Now, one more time. This is what makes this challenging, is looking at this in terms of letters that represent numbers that try to tell you what's going on, and sometimes it's hard to wrap your head around these vague descriptions, okay? So let's do some examples where we're actually looking at the properties and then we can see what this is really meaning, okay? So, but we do need to know what this is saying. Reflexive property says that, it's the same thing on both sides. Symmetric property means I can flip it around and it's still the same thing. So if I had something like x equals 5, that's the same as 5 equals x. Okay? This says if A equals B and B equals C, then A equals C. So that would say something like if X equals, I can't even come up with a good example. Never mind. We'll look at it, okay? Sometimes it's hard to come up with these on the fly. Addition property says you can add things to both of them to both sides and still get the same thing. This one says you can subtract something from both sides and still get the same thing. This one says you can multiply something to both sides and still get the same thing. This one says you can divide something by both sides and still get the same thing. This one says you can distribute and it shows you, when you multiply it equals this. And then we can substitute things in. Okay, so hang on with me. Don't give up. I promise it'll be okay. All right, let's look at example one. We have a lot of these examples, and they're meant to be kind of, just kind of weird looking. A lot of Greek letters in here, but it says identify the property that is occurring. All right, this is the Greek letter theta. Okay, so if we say theta equals theta, which one up here looks like that? Well, it's the reflexive property. So that's an example of the reflexive property. Okay, now here's another set of Greek letters. So if omega equals phi and phi equals delta, then omega equals delta. So let's look what happens. I know that omega equals phi, but I also know that phi equals delta. So what they've done is they've taken out the phi's and they've said, okay, well then omega must equal delta. This right here is an example of the transitive property. Okay. All right, letter C, we are going to distribute, and that's what happened, right? It looks like a distributing problem, and we can check it, and it sure enough is 8 times AB minus 32. So this is the distributive property of addition, property of equality. Distributive property of equality. You probably wrote them as POEs in Algebra 1, right? So when we put POEs on the end, we are saying like you can do it to both sides and it still makes it the same, right? So letter D. If we have this, then we know that 2x equals x plus 4. So what did we do? How did we go from here to here? Well, if you look at it, I added 3 to both sides, right? And so since I added to both sides, this is our addition, POE. All right, letter E. If beta equals epsilon, then epsilon equals beta. Okay, so we just flipped them around and said they are still equal to each other. So this is our symmetric property. Symmetric. Okay. If y equals 3, then 2y equals 6. Well, what did I do to go from y equals 3 to 2y equals 6? Well, I multiplied both sides by 2, right? So this is our multiplication, POE. And again, we put POE on the end, property of equality, because we've done it to both sides to keep it equal. If 7 pound, so we're purposely putting in some ridiculous things just to get you to see what's happening, okay? If 7 pound, or hashtag, whatever you want to call it, in my day it was a pound, okay? If 7 hashtag equals negative 14 at, then hashtag equals negative 2 at. Well, what did we do? I divided everything by 7, right? 7 divided by 7 is just pound. Negative 14 divided by 7 is negative 2. The at stays. So yeah, this is our division, POE. I promise they're not all this weird looking, okay? H, if 5x plus 3 equals 2x, then 3x plus 3 equals 0. Well, what did we do? We took away the 2x from both sides, and that gave us 3x plus 3 equals 0. So this is our subtraction, POE. Okay? All right. Now, that's identifying them. Okay, now let's move on and actually use them when we are well, not yet. We're still going to use them a little bit in just a general form. So let's look at example 2. It says use the property to complete each statement. Okay. There we go. All right. It says use the distributive property. Well, that's good. We can do that one. Let's distribute. That's going to be 18x minus 42, right? Easy breezy. All right, well, let's use the division property. The division property says if 4 times the measure of angle 1 equals 12 times the measure of angle 2, then the measure of angle 1 is. Well, we need to get the measure of angle 1 by itself. So how do I get rid of 4 times that? I'm going to divide by 4. Okay, and so 12 divided by 4 is 3 times the measure of angle 2. That's all I can say. That's how like, you're really just solving an equation. It's a weird looking equation, but that's all you're doing, right? We had to divide by both sides, divide by 4 on both sides, and then we know that the measure of angle 1 is 3 times the measure of angle 2. Okay? All right, C, transitive property. Now, the transitive property, it says if A equals BC and BC equals DE, then the transitive property says these two things, like we can skip the middleman, right? I know that A equals DE. All right, substitution property. We do this a lot. If we are going to substitute in, if I know that x equals 3c and r equals 5x plus 7, guys, we've done this, just not this weird looking, right? I know that x is 3c, so I'm going to plug in for x. So I know that r equals 5 times 3c, because now I know that x is 3c, plus 7. And we don't need to simplify it. We're just trying to prove the property, or trying to show the property right now. All right, the symmetric property means we can write it in any order we want and we get the same thing. So if it tells me that xy equals 2z, then I can tell you that 2z is equal to xy, right? I mean, that's obvious. The reflexive property says it's whatever it is equals whatever it is, like itself equals itself. So if I have the measure of angle ABC, I know that is equal to the measure of angle ABC. Okay, so let's actually use these in places, okay? Now, the good news is you have done this before in very beginning of Algebra 1, okay? So if you were here at Cap City, and even if you weren't, you should have been doing these uh, justifications, okay? So what we are doing, we are given that 3/5 x plus 1 equals -8, and what we are trying to prove is that x equals -15. Well, look what we did, guys. We just solved the equation. That was it, right? But now we have to justify our steps. We have to say what we did. That's all you're doing, okay? So if we have this, the first thing that we always say is that that is given to us, okay? We always start with what we're given. And so 3/5 x plus 1 equals -8 is my given statement, okay? Well, what did I do next? What did I do to this one to get down here? Well, can you see that what I did was I subtracted 1 from both sides? So that means it is the subtraction POE. Okay. Then what did I do? Well, if this is 3/5 x equals -9, and I got down here to 3x equals -45, I multiplied both sides by 5 to get rid of that fraction, right? So that was my multiplication POE. Okay. Then what did I do? Well, I have this, and then I went to this. So what did I do to go from here to here? Well, I divided both sides by 3. So that was my division, POE. And that's it. Okay. So you are just like, it's not changing what you do. You're just writing down your reasons why. And I know that seems kind of silly right now, and that's what I struggled with when I took geometry. But that's all you're doing. That's what a proof is. You are writing down why you did something. Okay? That's it. So this is kind of getting us ready for some bigger proofs, but it's starting with something that you know that you should have already done in Algebra 1. All right, let's do another one like this. Given that x minus 8 equals 3x minus 2, we are going to prove that this is the answer. Okay, well, the first thing, they've kind of helped us out here, and then they've left all our steps blank, which means we need to solve the problem. So the first thing we do is write what we are given. And in fact, that is our justification on the first step. It's given. Okay, now look at this. What would we do next? Well, they already told us it was the subtraction POE. So what are we going to subtract? Well, let's see. I would get the x away, right? So I'm going to take away the x, and that's going to leave me with -8 equals 2x minus 2. And that is proven with the subtraction POE, or justified. Okay. Now what would I do? Well, I would add 2 to both sides. And so that's going to be my addition POE. And so I am left with 2x equals -6. All right, well, they helped us out and they said our next step should be division. So let's divide, and that brings us to x equals -3. And then we are going to flip it around because we like to see it the other way, say x equals -3. So what property is that where we can just flip it around and it's still the same thing? That is our symmetric property. Okay. All right, let's keep on going. We got 2 more to do, and this one will involve things we are already familiar with. So we've got some blasts from the past in Unit 1. Angle addition, woohoo! So it says create and solve an equation for each scenario below, write justifications for each step. Okay, so let's start with what we know. If we look here, we know that this piece plus this piece equals this piece, right? So the way that I'm going to start by writing it is saying that AB plus BC equals the entire length of AC. Now, what told me that? That was my segment addition postulate. Okay, so again, you're just writing down what you know and why you did it. Okay, so, well, now that I know that, let's just plug in. Another word for plug in is substitution, right? So AB was 14, BC is 3x minus 4, and AC is 4x plus 4. So my justification for this step is substitution. You're just writing down what you did. That's it, okay? So don't think of it as more than it is, like it is an extra step, but that's really all you're doing. Okay, so what do we do next? Well, I'm going to combine like terms over here, and I'm going to say that 14 minus 4 is 10. So I'm going to write this as 3x plus 10, and I cannot combine anything over here, so I'm going to leave it as 3x plus 4. But what you write in a situation like this is also substitution, because we took 14 and -4 and substituted it with 10. Okay, so that's how that works. All right, so now I have this. First thing that I would do is I'm going to take away the 3x from both sides. And guys, I'm not changing what I would do. This is me solving it like we did back in Unit 1. Okay, since I subtracted on both sides, this step is going to be my subtraction POE. Okay, and so I'm going to be left with 10 equals x plus 4. And then I'm going to subtract 4 from both sides. Again, subtraction POE. And I'm going to get x equals 6. And if you want to write it down, differently and flip it around, you can. Most of the time we do anyway, and that is called the symmetric property. Okay, there we go. I did nothing different than we did in Unit 1. This is exactly what we did in Unit 1. It's just that now I'm writing down all my reasons why I did that. Okay, it's getting us ready to do some proofs. So this is kind of our first step, okay? All right, B. This is from Unit 2. We just took a test over it and you guys did pretty good on it. So 3x plus 1, 2x minus 6. I know that these two together are 135 because it says QST, angle QST is 135. So let's start with what I know. I know that angle QSR plus angle RST equals angle QST. Okay, now that is my angle addition postulate. Okay, I wrote that too big because now I'm going to have no room to write. So that's what we start with. We're like, okay, I know this angle plus this angle equals the big angle because that's what my angle addition tells me. Okay, well, let's go ahead and substitute in what I know. QSR is 3x plus 1, and I'm going to give myself more space so I have room to write my justifications over here. Plus RST, which is 2x minus 6, equals 135. So that step right there is substitution. Okay. All right, well, let's keep going. I'm going to combine some like terms. So I have 5x minus 5 equals 135. And again, that step would also be substitution. Okay, because I put stuff together and substituted 5x minus 5 for all of this up here. Okay. All right, my next step when I solve it is I would add 5 to both sides, and so I get 5x equals 140. That is my addition POE. Okay, I'm going to divide both sides by 5, and I get x equals 28, and that is my division POE. And I can stop right there because I got x. That's what I want. I don't got to flip it around or anything. We're good to go. Okay, hang in there, guys. You're doing great.